This is an entry for the ENCMP 100 programming contest, and my entry is a genetic algorithm for solving a platformer made in MATLAB. On the side of your screen you should be able to see the program actually executing, but what does it do? So it attempts to emulate evolution to solve a platformer by using a genetic algorithm. In order to accomplish this, you need hundreds of generations, each with several characters. And there are four main parts to it. The first part is that you need to actually run the character and have it run the platformer based on its genome. And then the second step is you need to select the characters that you want to breed based on a fitness, and then you need to breed and then mutate the characters, and then you just need to repeat it over and over again. So as mentioned before, each character has a specific genome. But what does this genome entail? It is composed of a series of actions, and each action has a specific time and a speed characteristic. Now, each action also has a type, and the two types that are in the program are jump and move. So the platform then loops through each and every character, executing each and every action in the character's genome until the character either dies or it reaches the end. If you look at the top left of the program, you will see the trajectories of the character, and that is reflective of the character's genome. Once a generation is actually run, new characters need to be made based on the breeding of the old characters. In order to accomplish this, first characters are evaluated producing a fitness value, and this fitness value is the sum of the distance travelled and the time that each character is alive for, minus the energy that the character uses, and then all of those are multiplied by a specific weighting, and the resulting number is then raised to the value of a differentiation factor. This differentiation factor actually separates the characters, so for example, with a high differentiation factor, characters that are fit and characters that are not so fit will have a greater difference between them in terms of fitness. The characters are then sorted based on their fitness, and then the breeding pairs of the characters are selected using a roulette wheel approach. This works by taking all of the characters and allocating each character a specific portion of a pie depending on the fitness of the character, so characters with larger fitness in relation to others will get a greater portion of the pie. Random numbers are then selected, and then they are allocated to characters based on their portion of the pie. So this means that characters with greater fitness values will be more likely to be selected by these random numbers, and then you just do this for all the different characters until you have selected enough to create the next generation. Then you actually need to breed the characters. In order to do this, what you do is you select a random point in the middle of the genome, and you say up to that point you're going to choose one parent's genome, and beyond that point you're going to take the other parent's genome, and then you just go and you combine the two together. Also, while in real life, essentially you have two copies of the same genetic data with some minor variations. In this implementation, you only have one chromatid or one copy. The characters are then mutated, and there's three different ways this is done. You add an action, you remove an action, or you simply change a characteristic of an action, so like the time or the speed with which the action is performed. Here's just some graphs and a timeline to provide a kind of general idea of what kind of steps were taken in this project and how long they took, and what actually went into it. So what can you actually learn from this? So one major thing is this idea of object-oriented programming, which is a model based on the idea of objects. Now, objects contain properties and methods are basically the same as functions, but they're possessed by an object, and by properties I mean values like integers, numbers, strings, and what have you. Now, the real cool thing about objects is that they can kind of build on top of each other. So, for example, if you had a vehicle object, you could have sub-vehicle objects such as sailboats and wheeled vehicles and cars and so on, and they can all inherit different things from each other. So, for example, all vehicles, they're going to move, right? But a sailboat could move through water, whereas a bike would move on land, and, a car would have all four wheels, and then you could just have different speeds for different types of cars and so on, all kinds of stuff like that. So what is the real advantage of this? And one of the ones is this idea of polymorphism, which is this idea that you can refer to a subclass by its superclass. So for example, if you had a bunch of car objects, you could refer to them all as cars, and then you could perform actions on them as a car object, such as, drive or turn or start the engine or whatever. And this can save you time because you don't have to code individually for each different type of car. You can just say all cars are going to drive, and then just have different speeds or whatever for each individual type of car.